This live Slooh show is brought to you by the support of Slooh members and the following sponsors. Visit slooh.com to become a member today.
Hi, and welcome to Slooh's latest live show. Today we're going to be talking about an asteroid that's making its close approach to Earth. But unlike a lot of other close approaches, this one is very intriguing not just because of how close it gets to us, but because of the dollar amount it could potentially be worth. We're talking today about 2011 UW158, also sort of nicknamed the $5 trillion asteroid, because it could contain somewhere between 300 billion and 5.4 trillion dollars worth of platinum. So we're going to be getting into that today. We're going to be talking about this close approach and asteroid mining and what it means to have an asteroid this expensive so close to us. I'm Eric Edelman, broadcasting to you live from Smoky Hollow Studios in Slooh HQ in Washington Depot, Connecticut. And tonight it's going to be a very fun show. You can ask us questions using the hashtag Trillion Dollar Baby, because I'm sure there's a lot you want to know about. Asteroid mining is a very new topic, and we're here to address your questions today. But for now, I'm going to bring in Slooh astronomer Bob Berman, and we're going to be talking. This actually is a live image coming in from the Canary Islands. We see, if you look at the center of the screen, you're going to see sort of a streak of light as opposed to the circular dots, the pinpricks, and that itself is the asteroid. This is a piece of rock out in space moving very fast across the sky, very close to us. And thank you. Welcome, Bob, for being here. Oh, here it is on the screen there in that circle. Thank you for joining me on this show. It's good to have you.
Well, it's great to be back here. You know, this is always exciting to have a nearby visitor. This is a PHA, a potentially hazardous asteroid, and it's one of the, I'd say, most hazardous because it's half a mile by a quarter mile in size. That's awfully big. It's passing only 1.5 million miles from us, just 6 times the distance to the moon, and that's today. Today's the day that we're doing it, and this live image from the Slooh main telescopes in the Canary Islands is pretty cool. I mean, it's moving so fast because it's so close that we're actually seeing it streak against the sky, and it's very cool. So even if it weren't a piece of gold, so to speak, you know, a valuable thing. And I know we're going to be talking about asteroid mining because this is not just a pipe dream anymore. The first steps are being taken toward it. It's still something that we want to keep our eyes on. So the Slooh members are watching this right now as it's skimming past us, moving through the stars of the Big Dipper.
It is, yeah. So I think we actually have an image that's showing sort of that its path is going to be taking tonight, actually through the show. Showing where it is in the night sky, and here it is. And so you see sort of red dots that are going across the sky, and you also see Ursa Major there in the center of the screen, which is the Big Dipper. The asteroid itself actually heading into the ladle of the Big Dipper, and so we here at Slooh were talking about it just a little earlier, that we've solved the asteroid mining problem. The asteroid's just going to land in the ladle. We're just going to pick it up. We're just going to bring it back to Earth. You know, we have it solved. But hey, if you think you can beat us, if you think you have a great idea for a way to mine this asteroid, use the hashtag #TrillionDollarBaby, as well as taking your questions. We're also going to be seeing maybe what sort of solutions you have and discussing those, and seeing if you guys can be the next planetary resources, deep sky industries, that sort of thing. But speaking of planetary resources, coming up later in the show, since this is an asteroid mining show, the president and chief engineer of planetary resources actually spoke to Bob Berman a little bit earlier. And this is Chris Lewicki, and we're going to actually hear what he has to say about this asteroid and about asteroid mining in particular. So that's coming up very soon. That's very exciting. But for now, we're looking at live imagery coming in from the Canary Islands. This is a Slooh observatory where we have, in the summer, 95% of the days are pretty much clear skies. So we love to be able to show you images from there. It's a great, reliable imagery observatory, about 8,000 feet above sea level. And so crystal clear nights all the time. And here we have that wonderful, beautiful streak. But so in terms of, you were just mentioning, Bob, that this asteroid is 6.4 lunar distances away. I mean, to put that, in our minds, we've landed on the moon before. We've gone one lunar distance. We've gone even further than that, though. We've just finished a week where New Horizons flew by Pluto, which is quite a bit further away. And so in terms of getting to an asteroid like this, would that be something reasonable for us to consider in the near future?
Well, it sure would. I mean, when you say Pluto, it strikes me as interesting that this asteroid appears exactly the same brightness that Pluto does. I mean, Pluto is a ball 2/3 the size of our moon, 1,473 miles in diameter. This is only half a mile in diameter, so it's much smaller. On the other hand, it's standing in brighter sunlight. The sunlight in our vicinity is much more brilliant than the sunlight that strikes Pluto. It's about 1,600 times less bright than the sunlight around here. So you put all those figures together, and how does it play out? Turns out they're the same. They're the same brightness, except this seems to be moving a lot faster. It is moving faster. Pluto's orbital speed is under 2 miles per second, and this is double that. This is about 4 miles per second relative to us. So as we watch it now, moving incredibly fast because it's so close to us. That's why it's a PHA, potentially hazardous asteroid. You can't come this close to Earth and not attract our attention. And it does so every 751 days, every 2 years roughly, in its orbit around the sun. We have a potential meeting with it. And that's one of the reasons why it's one of the objects you look at for mining, except this one seems to have a lot more goodies on board, and that's why the Planetary Resources Company has their eye on it. Because you don't just want an object that is a piece of rock that you can maybe get to. You want something that has some value to it. So it's a combination of things.
And as it's zooming through the sky, we're actually seeing it through different views. We were just switching in between two different telescopes that we have in the Canary Islands. This is our T1 telescope, where we're actually having our view centered, where the asteroid is in the center of the frame. And we also have a telescope T2, which looks at it from a bit of a distance, and it's also going to have, it's not centered in this. Watch the asteroid move through the star field. And so we're going to be tracking this at Slooh for a while. This is a half-an-hour show, but we're going to be tracking this for even longer. So if you're a Slooh member in the clubhouse, you can continue to watch it track after the show. But this is how it's zooming forward now. And so we're talking about different asteroids. Which ones are reasonable for mining, which aren't. There's different materials that asteroids are made of. So if I came to you, Bob, and I was like, I have this asteroid in the sky, and I want to know if it's profitable. I know it comes really close to Earth, but what material is it made of? Like, is there a way that you could observe this asteroid in order to figure that sort of thing out?
Yes, spectroscopically. And that's one of the reasons that the Planetary Resources Company isn't just hot air, because this is the third rocket they've launched to take a look at asteroids and determine what they're made of. In fact, the most recent launch was just a few days ago. So using spectroscopic techniques, that is reflected sunlight, and you can see what wavelengths of sunlight are missing, it tells you what the asteroids are made of. And generally, they come in three main flavors. Asteroids that are mostly nickel and iron, that is metallic, and some of us have samples of them in the form of meteorites. In fact, all of the 50,000 meteorites that are in collections and in museums, and or that you can even buy online if you'd like to, which is a lot of fun, they're all asteroids. They're all pieces of asteroids, except for maybe about 80 of them, which are fragments of the moon or Mars. But almost all of them are pieces of asteroids. So they can either be nickel iron, that is metallic, they can be mostly stony, or there's a third category, the carbonaceous chondrites that are made of organic compounds, and these sometimes have a lot of water in them. And the Planetary Resources Company has recently changed their focus from this type of asteroid, which has seems to have platinum in it, maybe as much as $5 trillion worth of platinum. Imagine that, to asteroids that instead have water in them, because it supply future astronauts perhaps elsewhere in the solar system. So water proves to be more valuable than platinum in the long run. It weighs 8 pounds per gallon. It's expensive to haul. To drag it out of the gravity well of Earth into space costs a fortune. It's one of the biggest expenses when you do space travel. So if an asteroid can be grabbed and you could bring some tons of ice back to the space station, you're saving a lot of money and making a lot of space exploration. Not just think in terms of gold and silver and platinum, but water, the most common compound in the cosmos, is a focus now on mining asteroids as well. Not this particular one. This is our, as you say, this is our $1 trillion baby. This is the platinum asteroid, which has, I think, a little bit more, cachet to it, a little more focus for us. It glitters in space, and it's passing so close.
And yeah, I mean, you're really right on the money, pardon my pun, in that regardless of what we're talking about, what type of asteroid we're talking about, it does boil down a lot to how much it's worth and where those dollars can go. And we're seeing your questions flying in on Twitter. Thanks so much for those. And we actually are going to be answering those very soon after we're going to be showing right now an interview with where Bob was previewing it a little bit with Planetary Resources President Chris Lewicki. And so we're going to be going to that. But before we do, there are a couple shows coming up on Slooh that we thought you should know about. And one of them is that we're going to be talking about how winter is coming. There is the talk of potentially a mini ice age coming up in the coming years, and we're going to be looking at the sun and talking about why that might be a thing this Thursday, July 23rd. So do come around and enjoy a solar show with Slooh on that day. And of course, we're going to be looking at some more things streaking through the sky a little bit closer to us. This is going to be a meteor shower, the Delta Aquarids, coming up in a couple Tuesdays from now. And so look forward to that as well. But right now, we're going to be heading into an interview with Planetary Resources President Chris Lewicki and learning a little bit more about how the companies that are actually carrying on the vision of asteroid mining, how they are executing right now.
Hi, this is Bob Berman, and we're very excited because the asteroid UW-158 is coming close to Earth today. And this is not just a near Earth asteroid, the kind that makes a lot of people afraid because they're worried whether it's going to hit us. This is an asteroid that got our attention because Planetary Resources is a company that talked about the asteroid a few years ago, saying that it contained as much as $5.4 trillion in platinum. And they're gearing up to mine asteroids. This is so exciting. So we're very pleased to have gotten hold of the company, the president, and the chief engineer of Planetary Resources, Chris Lewicki. And so thanks for joining us, Chris.
Yeah, it's great to be with you here today, Bob. It's UW-158, as in the short, of course, the full name 2011 UW-158. And I think a lot of people probably might be surprised to realize that we have asteroids kind of like this coming by the Earth system all the time. And every once in a while, they make a little bit better of a show for us. And I think this one is not disappointing.
All right. Now, when you said a few years ago that it contained as much as $5+ trillion in platinum, how did you come up with that number?
Well, it's a great question. So there are a tremendous amount of resources in our solar system, and up till today, we've only had access to those that are right here on the Earth, and that's served us well for a long time. But if we want to continue, we need to use the resources of space to help explore that next frontier. So the near-Earth asteroids are actually the next closest destination to the surface. 11 UW-158 is in our targets. It's not quite at the top of our list for a number of reasons we can get into. But we know run into the Earth and fall onto the surface. Platinum and the platinum group metals are one of them. Certainly, everyone's probably seen an iron meteorite in a museum, or maybe even got the chance to hold one. And then our near-term interest are the carbonaceous asteroids. So I think we've learned more about we'll call it UW-158 for short on the conversation today, but we're not as interested in it as we were now that we know that it's.
Why the carbonaceous asteroids? What do they have that would be more valuable than platinum? Platinum sounds pretty good to me. What are you
Well,
looking for beyond platinum then?
yeah, so platinum is extraordinarily valuable, and I say that elements are among some of the most useful elements on the platinum or on the periodic table. And it happens to be that these metals are relatively scarce on the surface of the Earth, so they end up having a fairly high price here in our market. But aluminum was once that way as well. And when we figured out how to extract it from bauxite, and it went from being the rarest metal on the planet to perhaps the most common metal on the planet because it's the most abundant in the Earth's crust, our relationship with aluminum changed entirely. And we'd like to work through our roadmap so that in a perfected industry where space resources are part of our sphere of influence, platinum can be used for what it's best at, and we don't need to worry about the price tag when we pick it up. So,
Huh.
speaking to carbonaceous asteroids, our interest in carbonaceous asteroids is with the very simple molecule of water. And we're, of course, all very familiar with water. It's the essence of life. And there's plenty of water on this planet, maybe not as much fresh water as we'd like, but plenty of it in the seas. The problem is, sending that water into space is extraordinarily expensive. And even if the launch were free, it takes an incredible amount of energy to ship that much mass around. So when we can get water in space, we'll be able to both support human activity and human life. We'll be able to shield us from the radiation that's we're exposed to in space. But perhaps most interestingly, we'll be able to refuel our rockets with the hydrogen and oxygen that is present on the carbonaceous asteroids in our solar system.
That is so cool that you've made a change, and it's totally logical from precious metals like platinum to the most common compound in the cosmos, water. But it makes perfect sense that in space water would be even more valuable for all of them. So that brings up the question. Resource mining, of course, here on Earth it has its dangers. It's proven to be environmentally and physically challenging. So are there similar concerns for asteroid mining?
Yeah, well, one comment is I wouldn't say we've made a change from platinum to water. It's just this is the roadmap and the order that you would develop things. You start with the easiest and perhaps the most important resources first, and we'll get to the platinum is more challenging to extract, but also very valuable. So in terms of resources on Earth and our mining them here, and as you had mentioned, the challenges that we experience in doing that, a lot of those challenges are because these mines are next to the places that we'd like to live, or in, of course, the beautiful environment that we have on this very precious and sometimes fragile planet. So what we need to realize is that the Earth, as my co-founder Peter Diamandis says, is in a crumb of a supermarket of resources in our solar system. And asteroids have been orbiting our sun for the billions of years that the sun has existed. And they're really out there available for our use. And this is one of those ways we can really take where we live and our environment and now separate it from the places that we get our resources to support our families, our livelihood, our industries, and our economy. And this is something that I'm very excited about because in some ways, maybe the best way to preserve our environment and our planet is by finding new options for energy and resources and everything that we need to support our quality of life.
Huh. Now, when do you think this might be practicable? Are we talking about far in the future or just the next few years?
This is the next few years. As your viewers may realize, we're very excited to celebrate the deployment of our first satellite from the International Space Station yesterday, on July 16th, the 46th anniversary of the launch of Apollo 11. So a historic day for history, and certainly a historic day for planetary resources. The Arcade 3 is the first in a series of technology missions that we're developing. We find what works, what doesn't. Our next launch is coming in December, and in the mission that we're scheduled for December, we'll test out sensors that allow us to detect the water on asteroids, so that we can look in the infrared, and we can look at the chemical and mineralogical signatures of asteroids. And so when we're in orbit in December, we won't be able to quite point those at the asteroids because they're still quite far away, but we can test that sensor out on the surface of our Earth and be ready for the measurement to be working for us when we take that sensor all the way to a near-Earth asteroid. So after that, we will add in a propulsion capability, which we're working with NASA right now for 3D printed structures and propulsion systems. And then ultimately, just a few years from now, probably in 2018 and 2019, we'll be deploying the first Arcade 300 swarm constellation out to a near-Earth asteroid. Maybe UW-158, maybe others, and we'll begin the era of prospecting and exploration that is so critical in any area of resource exploration, whether it's on this planet or off.
Now, would you initially, if you're extracting water, would you initially bring it to the International Space Station, which certainly needs water, or am I jumping the gun here, or would that not be a target?
I think we'll have a number of targets. Taking a step higher for a moment, everything that we send into space has to take with it everything that we'll need for its entire lifetime. And for the space station, we are fortunate to be able to send resupply missions from that in the past year. So certainly being able to send water to the International Space Station that's up there right now is a very useful thing to do. What I'd like to think is that a source of water and rocket fuel will allow us to actually build more space stations and allow us to take everything that we're sending up in space and send just the complicated bits that we build here on Earth and bring the dumb fuel from space. So whether it's a fuel depot in low Earth orbit, in a Lagrange point in the Earth-Moon system, or perhaps on the way to Mars, we'll bring the fuel back to where it's most useful. And just like you see the corner gas station in the high traffic areas and where people spend their times visiting and perhaps passing by, it'll be the same type of market dynamics and economics that will decide where the fuel will be brought to in our Earth system.
And so really, no matter where we are, whether we're on Earth or whether we're out flying through the depths of space, water is pretty fundamental. I mean, I think that's one big takeaway from here. But yeah, well, everybody, welcome back to the live Talking Heads. I hope you enjoyed that planetary resources interview. It's really great to get that amount of perspective on these asteroids streaking through our night sky, what we can do about them. And so here you see, sort of in the center of your frame, this is from one of the Canary Islands telescopes, that streak of light as opposed to the circular dots. That is the asteroid. That's UW-158. That is the $5 trillion baby. And so welcome back with me, Bob. I think we have a ton of questions. People are really curious about this subject. But before we get into them, you have any sort of thoughts about the interview that just went on?
Well, I do, because there's one other aspect, and that is the 1967 Outer Space Treaty, which is what almost every country in the world signed. And the idea, and this is a little tricky here, because the idea was that no celestial body is owned by any nation. Now, remember, that was signed just around the time that we went to the moon, the first moon mission. And so the idea was no country can land on the moon or on an asteroid and say, it's ours. This belongs to the United States or belongs to Russia. And so we're a signatory to that. But there was nothing in that treaty about commercial entities. So what happens if a company like Planetary Resources goes out to an asteroid such as the one that's passing by today and that we're watching live here at Slooh? Can they say, this is ours, we're going to extract the platinum or the water, we're going to make a profit, we're going to mine it? And the issue is actually a little vague. There's a bill right now before Congress to try to clarify that, but the way things stand right now, it's a little iffy. A nation cannot claim a celestial body, but apparently a commercial entity may be able to. So this has to be resolved. This is one of the who owns these things? Who owns the sun? Who owns these objects? So that's another aspect as we watch UW-158 now zooming past us, passing through the stars of the Big Dipper here live at Slooh through the Slooh telescopes. This is fantastic that we're watching this live as it's actually skimming past us 30 times closer than the nearest planet, Venus. This is kind of a near miss, isn't it?
It's really close. And so there's actually a Twitter question coming in from Twitter user Dosemi Mediocre, who's asking about the $1 trillion baby, and would it be possible, they asked, to direct a large metallic asteroid into an ocean, picking up the remnants when you just you throw it into the bathwater and see what's left there? What do you think about that, Bob?
Well, it's a great idea. We can't do it right now. And there are a number of problems because if you want to change the orbit of an object and you set off an explosion, you might instead turn the asteroid into a million pieces that rain down as a meteor shower. So the actual mechanics of changing the orbit of an object that's passing nearby has to be ironed out. No, again, no pun intended, because these things are not slow. This particular one that we're watching right now has a speed of 4 miles per second. That's 8 times faster than a high velocity rifle bullet. And an object, even though it's only half a mile by a quarter mile, you don't change the mass, the orbit of an object easily. This is not a trivial thing to do. So when you apply some sort of force, it wants to resist it. So how you do it, I think it's a wonderful idea to bring it down into an ocean without creating, of course, a tsunami so that you get lawsuits from every sea level city in the world, and without it turning into thousands of fragments of meteorites. Imagine platinum meteorites raining down all over the world and everybody rushing out to grab pieces of platinum. You know, I'm exaggerating a little bit, but it just shows this questioner is asking, just opening up the door to some of the intriguing.
Again, we see it as this giant in the center of the screen, this streak of light, as opposed to the pinpricks on the screen. Within that circle, that is that's the $5 trillion baby. That's where it is. And so we have a great question that just came in from Tom Courtney, who's asking about the water of it all. And if we were to mine this water, so to speak, is water 100% recyclable when used by humans in space, or is it some of it lost? How much of an efficiency could we get when it comes to that space water?
It's getting more and more efficient. Even the Apollo astronauts going to the moon had recycling capabilities, and these days water is more easily generated by actually combining hydrogen and oxygen. That's one of the things that exploded in the Apollo 13 near tragedy, cataclysm, was you use hydrogen and oxygen to create water. And in doing so, it also creates energy. So a lot of things go together with it. So currently in the International Space Station, there are elaborate ways that, I don't want to get too gross here, where urine and other water byproducts are reused. And because it's so precious, at 8 pounds per gallon, it costs a fortune to bring it into space. So you definitely don't want to just throw it out.
Yeah. And so, money. Really, money's the topic at hand here. And Bella on Twitter asks, does anybody have the right to appropriate something that's extraterrestrial, that's outside of Earth, if it's for profit? Like, who gets the money? And you were talking a little bit, Bob, about some of the stuff that's going into that. Do we have standards set in place? Is that currently being developed right now?
Well, it is. That's the bill before Congress. Now, Congress has a bias towards letting corporations, just saying, sure, you go up and you're going to go through the expense of engineering this and getting it, it's yours. But I think the end result there's going to be some taxation or sharing or revenue or something. The last word hasn't been written with this because, after all, if nations cannot just claim a celestial body as their own, I don't think we're going to just let companies do it and own an asteroid once they just simply go there. Uh, or are we? You know, this is the issue of this year. It started with the 1967 Outer Space Treaty and has not been readdressed until now. But now that we're, I think, just within years, as we've seen, of actually mining astronauts, that does have to be solved first.
There's a lot of issues that are coming into play, and as we're thinking about them, there's issues on Earth, there's issues on the asteroid, and there's lots of different things to be talking about, really. I mean, one of the things that I'm seeing a lot of people being surprised about is the actual just the live imagery that's coming out right here as we're seeing it. Like, why can we see a streak? Like, how is that working? Like, as opposed to just a standard pinprick of light. Like, why can we see that quote unquote movement of the asteroid?
Yeah, because it's moving so far in the telescopes towards the exquisite detail of Jupiter's cloud systems or the rings of Saturn. Saturn is beautiful these nights, or those cobalt swirls of galaxy spiral arms with those campfire orange cores of galaxies. I mean, Slooh does full color live, no color enhancement images of the universe, and it just takes your breath. Have any color to it, and a completely different capability of the great Slooh telescopes is being used, and that is that the object is so close to us tonight, UW-158, as it zooms past us against the stars of the Big Dipper. It's really moving through a chunk of the Big Dipper just during this one show. That's how quickly it's moving. So it's no problem during these live images for Slooh to repeatedly look at it and see it as a streak as it's passing through those background stars of the Big Dipper. So very cool capability here, and fairly easy to do when an object this large, and it is pretty large, at half a mile by 1 mile, I'm sorry, by 1/4 of a mile in diameter. That's plenty large enough. Its magnitude 14 point means you can't look up in the naked eye to see it. It's about, well, 100 times 100, what's that, 10,000 times fainter, 10,000 times fainter than that. So you really do need powerful telescopes.
Yeah, and actually, one thing that Slooh members do a lot is we actually have a Space Act agreement that Slooh signed with NASA just the other year, where we are getting into hunting near-Earth asteroids and being the connection between the professional and amateur astronomers. So amateur astronomers are also looking to make sure that they can track these asteroids and making sure that there's not anything that's necessarily going to hit us. So we actually use these telescopes and do some really fun science with it as well. But I'm just amazed by how much ground we've been able to cover through this show, Bob. We've been able to talk about near-Earth asteroids. We've been able to talk about how to mine them. We've been able to talk about the different types of asteroids you'd mine, what it all means. And there's so much into this topic. And I think it's really refreshing to not just be talking about asteroids in an apocalyptic sort of sense, because we always talk about, oh, this asteroid's going to be coming close. It might be really close. We're a little nervous about it. But now we can talk about the fact that, oh, what if we go to the asteroid instead of the asteroid comes to us? And so this is just, the development of science, humans going further than they've gone before. We're bashing through walls and new frontiers. And it's so exciting to have this sort of dialogue and conversation. And as we get to unfortunately, the end of this show, do you have any sort of last thoughts about this whole menagerie of excitement that comes with asteroids that get close enough for us to imagine maybe taking part of them back?
Yes, that's exciting. We looked at the science, we looked at the peril, we looked at the greed. This is interesting combination tonight of greed and fear. What's going on with this? But there's yet another aspect of these celestial objects that we're going to get into very soon, and that is beauty. Because very soon we have the Delta Aquariid meteor shower, followed by the best Perseid meteors in years, because the moon is going to be ideal. Plus, we're going to have 2 nights of the Perseids rather than the usual 1 night. So we'll have, it's not listed here because that's a little bit further out. It's a few weeks from now. But we're also going to see these celestial bodies the ones in our solar system that are not moons and planets, the ones that are not Pluto, etc., um, giving us a sky spectacle that will appeal to our aesthetic side, our sense of beauty, not just our sense of, hey, what's in it for us? So, a lot of different aspects of astronomy, and it's great to look at these live Slooh followings of this tonight. Look at that, how quickly it's moving. You know, we had our red circle near the middle of the field of view just when the show began, and so zooming through the through Ursa Major so quickly because it's so close to us. Wow, quite an
It's
exciting thing.
Absolutely. It's one of those things in astronomy where astronomy is on scales so gigantic, time scales so long. You know, you're talking in terms of billions of years, trillions of dollars, really, really large numbers. But just in the period of a half hour, we've seen this really significant movement of this asteroid that's very close to us. As it zips across the screen. You've seen it here. We're actually going to be tracking it for a little while longer, so members in the clubhouse that like to look at the live telescope imagery can continue to look at that for a bit longer. But yes, you know, you were mentioning that we have a lot of shows as well coming up on the horizon. We are going to be talking about winter and what that might mean in a few years, if in terms of potentially a mini ice age, as well as potentially the meteor showers coming up, the Perseids, as you were mentioning, and also the Delta Aquarids. We're getting out of our dry season of meteor showers, and we're going to be seeing a lot more shooting stars coming up as the months get into the higher digits. And so that's a fun show. We're so happy that you've come along with us for the ride. There's a lot to talk about, and of course, we'll do asteroid shows whenever there's a close approach to be considered that's has some sort of story behind it, like this intriguing $5 trillion asteroid. And yeah, thank you again for watching. Thanks to our Slooh members for tuning in as well. And we're going to be back before you know it. But for now, this has been Eric and Bob for Slooh. Goodbye.